Okay. So this section is talking about intercepts, and there's a couple ways you can find them. Okay, so the first thing we have to know, intercepts are points. Intercepts are points where the graph intersects the x and the y axes. Okay, so these are the points. The graph can be in any shape that it wants. What I'm looking for are the points, okay? And so to state a point, it has to be x comma y. All right, make sure that you state a point with parentheses and the two values, okay? So I'm looking at this graph over here, okay? The computer probably should have drawn some arrows, but it didn't. And we're trying to find the intercepts, okay? So right here, this point, the graph crosses the x-axis. And how would I say that intercept point? -5, comma 0. Now that's not the only intercept. There's lots of places where this graph crosses the axis. Okay, here's another one. And we have to state it with parentheses, -2, comma 0. And there's one more way over here. Okay, put a point and then label it parentheses 4, comma 0. Okay, did I get all of them? No, there's one I missed.
-40.
Yes, but we have to state it as a point. So what would go first?
The 0.
Yeah, 0, comma -40. Okay, so you have to always have a 0 for an intercept. If you're on the y-axis, then the y number gets the number, and then the x value is 0. Okay, so look all along the x-axis and look all along the y-axis for your intercepts. Getting intercepts off a graph is fun, and people say it's pretty easy. Okay, algebraically, how can we do this? Okay, to find an x-intercept, I'm noticing here all the x-intercepts are nice numbers, and the y value is always 0. Okay, so what we're going to do to find an x-intercept algebraically, okay, algebraically, you let, okay, or you make the y value equal to 0, and then you solve it. And don't forget, your answer is going to be number, comma, 0. You should remember all this from your algebra classes in the past, okay? To find a y-intercept, you want the y number, so you let the x number equal nothing. 0 for x, and you find the number for y. Y-intercept gets a y number, okay? All right, let's do an example. Okay. To find the intercepts for this one right here, to find the intercepts, I'm going to organize my work. I have to find an x-intercept, and I have to find a y-intercept. So let's just do one at a time. To find the x-intercept, we're going to let the y number equal 0. Okay? So this y value is going to 0 out. 2x plus 3 times 0 minus 24 is nothing. 3 times 0 just cancels out. 2x minus 24 is 0. I'll add the 24 or move it to the other side, and x is 12. Okay, so we just found the x-intercept. Is that good? Hang on, that's not how we write it. Okay, remember, intercepts are points. Okay, so you can't say it like this. This would be like if you were solving an equation. Okay, the intercept has to get written as 12, comma 0. Okay, that's the intercept. All right, let's find the y-intercept. To find the y-intercept, I'm going to let the x equal 0. Now, what some people do is they use the cover it up technique. If x gets zeroed out, that part of the equation completely goes away. You could just cover it up with your finger, and all we have left is 3y minus 24 is 0. 3y is 24, and y equals 8. Except we can't say an intercept like that. We have to say it like a point. 0, comma, 8. That the value goes in the y spot. Okay. Any questions on finding intercepts algebraically? Good so far? Okay. We've got one more graph right here, finding the intercepts from a graph. Okay. And so what I'll do is maybe make a list right here. Let's list all the X-intercepts and let's list the Y-intercepts. So look along the X-axis. The first point right there. Don't forget the negative sign. 1, 2, 3, 4, 5, 6. I think we're at -7, comma 0. Look along the x-axis again. Here's another one. 1, 2, 3. -3, comma 0. And there is a third one right here at +3, comma 0. And then any y-intercepts, this graph seems to have one right here at 0, comma -3. Don't forget those negatives. Okay, so even if this graph was fancier and went up and down and up and down and had several more curves, okay, what are you noticing about the number of x-intercepts? Could a graph have 5? Could a graph have 6? I mean, if the graph was fancy, it could have 7. Okay, so in terms of x-intercepts, the graph or the equation can have many. How many? As many as it wants, infinitely many. Okay, but in terms of y-intercepts, if it's a function, functions can have only one y-intercept. And I look at the graph right here. Does anyone remember a rule about how you could figure that out? It had a fancy name. If you draw a vertical line, the line can only touch once, okay? So you can't have two y-intercepts. If you're a circle, that's a pretty graph, but that's not a function, okay? Every line that you draw should only touch once.